All right, welcome everyone. I'd like to start with the acknowledgement of country. We acknowledge that the University of South Australia is on the traditional country of the Kaurna people of the Adelaide Plains. We recognize and respect their cultural heritage, beliefs, and relationship with the land, and we acknowledge that they are of continuing importance to the Kaurna people living today. So welcome to our team project presentation. This is the capstone of the SHSSP program here. 4 weeks of hard work, starting with so many core lectures that I think I saw a lot of you falling asleep at the end, culminating into this final deliverable, this project that I'm happy to share today with 29 students, 3 subgroups, all towards the common goal of researching and finding some solutions for the lunar search and rescue topic. I'd like to introduce the 3 assessors who are here on site with us. So Lan Snell is the Dean of Programs, the Postgraduate Programs at UniSA Business Department. I don't know if I'm saying that right. Michael Davis, the Chair of Andy Thomas Space Foundation, and Adi James, the former Southern Space Hemisphere's Space Studies Director. Online, we have Francois Spiro, the French Prime Minister Office and European Space Agency, France representative, Juan Ledamo, former ISU president, ESA retired, Communication and Strategy Department, Judith Hayes, NASA Chief Science Officer under the Human Health and Performance Directorate, Suyin Tan, former ISU Dean, currently at Waterloo University, Maurizio Natti, ESA retired, Special Advisor to the Space Activities, Rodrigo Ventura, Associate Professor of the Electrical and Computer Engineering Department of the Instituto Superior Tecnico, Daniel Rockberger, Entrepreneurship, NSL Com, Eric Dahlstrom, NASA retired, Space Base New Zealand, resident faculty of ISU Central Campus. So we have all of those prominent people and the 3 here in the room, and we're ready to pass it on to the presenters.
The participants of the Southern Hemisphere Space Program 2025 respectfully acknowledge the Kaurna people as the traditional custodians on the land which we have lived and worked during this 4-week program. Throughout this time, participants have had the privilege of immersing themselves in Kaurna land whilst also exploring humanity's deep connection to the sky and sky country. SHSSP25 has fostered a rich exchange of knowledge, spanning space science, diverse cultures, languages, interests, and perspectives. Meaningful conversations and lasting friendships have formed, reinforcing the power of shared discovery. As the world enters a new era of space exploration, this journey has underscored that exploration is not only about pushing the boundaries of the universe, but also about understanding our own.
With that, welcome and thank you all for joining us here today at the University of South Australia Mawson Lakes campus. I'd also like to give a warm welcome to any ISU faculty, to esteemed guests and friends and family who may join us online. My name is Linda, and I'm excited to be here today together with Jasmine as part of a team of 29 participants representing 12 different nations to talk about our team project on the topic of lunar search and rescue. Our presentation is going to last for about 60 minutes, and we also have an interactive session where we're going to ask you to take part in so we can test our color code. And after that, we're going to have a 30-minute Q&A session where we are happy to answer any remaining questions there might be. And with that, we're going to start with a short video as an introduction. human presence on the moon is increasing. There are more and more missions planned. Emergencies can happen anywhere, but on the moon there are unique challenges to that. Unlike Earth, where help is only a call away, there's no search and rescue team on the moon, and there's no lunar distress system in place yet. But what happens if there's an emergency for an astronaut? What if they face a medical emergency? What if there's a malfunction of their suit? Or what if they simply get lost? How can they communicate that there's a problem? For this, we have our two key questions, which is, how can we design a lunar distress signal that is simple, clear, and at the same time effective? And second, what challenges will we face in implementing such a system? For that, we created Selene. Selene is our color-based lunar distress code. We use simple, universal, recognized colors in order to classify an emergency. This classification helps us to then send and understand better what kind of help is needed in this specific situation. And with that, I'm going to pass on to Jasmine, and she's going to talk about the challenges we face with lunar distress messaging. Thank you.
Thank you, Linda. You may be wondering why we need a universal lunar distress code. Well, distress signals are typically sent by low-power beacons, which means that messages must be concise to ensure reliable transmission. Ensuring that distress messages are prioritized and retransmitted accurately is crucial for rescue operations. In light of these constraints, a universal lunar distress code that is simple, concise, and easily recognizable is necessary to safeguard humans conducting space activities on the lunar surface. A color-based code can convey critical information quickly without requiring lengthy messages, thereby maximizing the efficiency of limited communication infrastructure. The lunar environment has far less communication infrastructure in comparison to the Earth. Unlike the extensive COSPAT-SARSAT system that provides global distress signal relay, the Moon's infrastructure is still in its infancy. The proposed LunarNet system aims to bridge this gap by solving scheduled communication issues, providing high-precision surface and orbital navigation, and the receiving of distress messages. With fewer satellites and no current infrastructure, the transmission of large distress messages may not be feasible. Currently, there is no standardized emergency code for lunar operations. As lunar exploration and habitation become more prevalent, the likelihood of emergencies will increase. Without a universal lunar distress code, communication during emergencies could become chaotic, leading to delays in rescue operations and potentially putting lives at risk. And with that, I'll hand you over to my friend Anush to elaborate further.
Thank you, Jasmine. As we set our sights to deeper space exploration, one question comes to our mind. Are our current systems ready for the challenge? Unfortunately, a few limitations come to our mind, like infrastructure, bandwidth, and power. Speaking of infrastructure, the coverage is limited. The setup costs are astronomical, pun intended. And challenges with signal reliability still remain. Building a resilient network beyond the Earth is not just difficult, it's essential. Speaking of bandwidth, the bottleneck. Large bandwidth requirement is always there when doing space communications with larger volumes of data. This can bring in increased delay rate and increased error rates. Efficiency is of prime importance. Especially in case of emergencies, slow transmissions can make a difference between life and death. Coming to power, another hurdle. Large payloads always demand more energy. This brings in complexity and also another complications like power consumption. Every watt matters in space, and any inefficiency can make a difference, can cause or jeopardize the mission success. If we want a future where our astronauts can safely explore the space, we must rethink and revolutionize these systems. The next step in building space rescue begins today by facing these challenges. As humanity plans for longer lunar missions, critical questions comes to our mind, like what do we do if there is an emergency on the moon? How do we handle these contingencies? Looking at space-based or current terrestrial-based search and rescue systems, there are a few limitations. Let's look at them. Apollo missions, who cannot stop admiring Apollo missions? They did have a giant leap in terms of space exploration, but emergency protocols took a very small step. They had only basic emergency procedures on the way to moon and no strict protocol for the lunar surface. Speaking of ISS and Tiangong, they have been orbiting around Earth for decades together. They do have extensive emergency procedures and protocols, but they are only bound for Earth-bound orbits and not for the moon. Speaking of terrestrial search and rescue systems, they always rely on police, maritime, and medical services, which are often complex, inconsistent, and often prone to miscommunication. The emergency beacons provide very minimum information, which leaves the responders guessing for the next course of action. As humans plan for long-duration lunar activities, it is clear that we need a new and dedicated approach for solving these search and rescue operations and systems. And Moon provides unique challenges, and our survival will depend on how well we adapt to it. I now make way for Andrew, who will take you on a journey from Earth to Moon.
Thank you, Anush. Now, Moon and Earth, closest companions in space. So close, but yet so different. Take communication, for example. While Earth is blasting in all frequencies possible 24/7, on the Moon in silence, broken only by solar wind and occasional crash landing of yet another moon rover. Or atmosphere. Earth, well, it got one. One moon has numbers so small it makes vacuum jealous. What about gravity? Earth keeps firm grip on things at 100%, while Moon takes more relaxed approach at 16%. Or search and rescue. Here on Earth, search and rescue teams stand ready, while on the Moon, let's say commute times take a bit longer. And once they have arrived, they have to deal with gravity, which, as you can see in this video, is an acquired skill. For these struggling astrophysicists, every movement is a delicate space ballet where each stumble is a next step towards letting it go. On the positive side, you can perform kangaroo hop, bouncing up and down, everyone is a bouncer on the move after all. Not only that, you can practice some other breakdancing moves in preparation for the next Space Olympics. But enough of this foolishness. Let's talk about time. One day on the Moon is approximately 14 Earth days. So consider that before you accept your next night shift on lunar surface. And what about temperature? Not to be forgotten. Plus 200 degrees Celsius during the day, enough to melt tin metal, and minus 180 during night, so even liquid nitrogen feels warm and cozy. Or radiation. Here on Earth, we are well protected by our magnetosphere, while on the Moon conditions are substantially more extreme, where such protection is lacking, and no SPF 50 sunscreen is not going to help. Speaking of extremes, let's look at the permanently shadowed regions. These areas haven't seen sunlight in millions of years, literally coldest places in our solar system. But these areas hold secret. They have ice and other volatile compounds that would vaporize anywhere else on lunar surface, waiting there for the next generation of explorers. Now with that, I hope that I've persuaded you that Earth and our only natural satellite have some differences, and I will hand over to Sia, who will talk to you about mission objectives.
Thank you, Andrew. So after we identified these gaps and these limitations, it brought us to our final mission objectives. So first up was to design a dedicated universal distress code, specifically for lunar search and rescue. And in terms of this, we also wanted to investigate its feasibility from a technical and a legal standpoint. So introducing our color code finally, we have named it Selene, the goddess of the moon, but also it stands for a system of emergency lunar event notification and escalation. So this color code we've split up into 7 distinct codes. Now, I hope you're all paying attention. We will be quizzing you on these later. But each code has been designed specifically for certain emergency scenarios so that we can allocate our resources best and make sure that each scenario is being responded to effectively so that we don't risk loss of life, we don't risk loss of mission either. Now, a key part of this is to actually define an emergency, which we've defined as a severe unexpected scenario that requires immediate action. The key part of this is the immediate. So this isn't a beacon that you're going to use that you have an issue that can be fixed in a week or with the next resupply mission. This is something that needs to be actioned immediately. Otherwise, again, you will have either injury, loss of life, loss of mission. Now, this code is designed to be used when all your other communication methods have failed, similar to emergency beacons that we have on Earth. So I'll first introduce code red. So code red refers to life support failure. Now, we have ordered these codes somewhat in order of urgency, so that in the case of multiple emergencies, we can know which ones need to be actioned first. Now, life support failure refers to an immediate danger to life as a result of your life support systems failing. So your EVA suit has depressurized, your lunar rover has a rupture, your oxygen system is compromised. Or as Andrew mentioned, the moon can get extremely cold, negative 180 degrees Celsius. So your thermal systems are absolutely a life support system. And say you're stuck in lunar night, you don't have any thermal systems, that can be something that necessitates this beacon. Now we're talking seconds to minutes in the danger level here. So we will need a medical team and we will need an engineering team so that in the case of any medical emergencies, as a result of your life support systems failing, you can administer aid, but also an engineering team so they can fix the issues before continuing. Now we have code blue up next. So code blue is completely medical. So it has nothing to do with any of your engineering systems. It is completely to do with a medical emergency, similar to what we would have here on Earth, that would necessitate a paramedic's response. Now, the key part here is that this medical emergency requires on-site attention. So something like a heart attack, a stroke, loss of consciousness, you've broken a bone, that you need a paramedic or a medical team to come rescue you before transporting you back to base. Now, I will hand over to Vincent to continue explaining these codes, but definitely pay attention. There will be a quiz. Thank you.
Thank you very much, Sia. So the next code on our list is code orange. Now, unlike code red, this deals specifically and only with engineering system failures or critical engineering system failures that may result in later escalations to differing emergencies that may cause harm to astronauts or other members of crew. In this case, we can imagine small fractures in a helmet that might cause, let's say, discomfort for an astronaut, but not necessarily depressurize the EVA suit. In these cases, you may not want to move much more lest you fall and the crack worsens, causing a depressurization event. In this response, we suggest that the engineers or whoever is active not move and an engineering team, be dispatched to fix the issue before any further escalation can occur. With the next code that we have, code purple, we have an aggravated persons code, I like to call it. In this code, it's in essence anything that is due to human escalation or even perhaps malcontent. So we can imagine physical altercations, breaches in safety, deliberate breaches in safety perhaps, and in these situations we always require the response of a bit more of a forceful team, so something like a security team or some personnel who can de-escalate the situation. With our next code, code black, this is a missing in action code. So this in essence, is when we have lost communication with a specific crew member or a other person, perhaps, say, from a Chinese lunar base, and we know roughly their last location. A search and rescue team can be dispatched to this last location to initiate a search and hopefully find the crew as quickly as possible. In these situations, we have quite a high amount of urgency because of the lack of communication. We don't know whether the individual is in a healthy state or if they have any systems that need to be repaired. So this is also quite an important case to consider, but it doesn't take priority over the other cases previously mentioned. Now moving on to the next code, code green. I like to call this one the stranded code. So in essence, communication and health systems are completely online. Everyone is fine, but perhaps the navigator has ceased to work, the astronauts can't find their way home, or any other immobilization has taken place where the astronauts are no longer able to travel. In this case, any available personnel for pickup can be dispatched. In the case of perhaps a rover system, this might look like a mechanic team. This is in stark contrast to the next code, which is code yellow. Code yellow is specifically with respect to radiation hazards, so coronal mass ejections or solar storms, if you prefer. This code requires the response of individuals to seek shelter, a safe place, preferably radiation shielded, perhaps even a rover or some temporary shielding if that should be available. Now, with these codes, I would like to pass on to Jerry for the interactive session that we have now. So thank you very much.
Thank you very much, Vincent. I now invite everyone to join us in an interactive session to test everyone's understanding of the Selene color code system. So if you could turn your attention to the screen, there is a QR code on there that you can scan to join the session. Alternatively, if your phone cannot scan a QR code, there is the website link there, ahaslides.com/R4CZY. So once you enter the website, you'll need to enter your name in order to join the session. And then during the session, you can refer to the color handouts that you have in person, or we will later put it up on the screen. And according to those color handouts, you should be able to choose your answers for the 5 questions we have created to simulate certain possible emergency scenarios that can occur on the lunar surface. And there will be a total of 8 options, so 7 are the color codes, which we have mentioned before, and number 8 is a non-emergency option. So if you could choose the response that you think is the most appropriate for each situation, and most importantly, don't forget to press submit at the end, or we won't be able to receive your answer. So I'm just going to give it a little bit more time before we start. And keep in mind, these situations are multifaceted and have very different components that you need to consider. So take your time to answer. You'll have 1 minute to answer each question, and make sure that you put careful thought and consideration and try and get it right. Okay, let's start in 20 seconds. So please make sure that you have joined the session and are ready to go in 20 seconds. And as a reminder, these are the 7 codes that you can choose from, including 1 more non-emergency option. Okay, shall we begin? All right, question 1 of 5. While on an EVA, extravehicular activity, your commander suddenly drops to the ground, unconscious. In this scenario, what do you do? Now, as a reminder, you only have 1 commander, and they're pretty important. So let's try and select the most appropriate response for this question. Twenty more seconds. This is quite indicative of the actual scenario where you will only have a limited amount of time to choose which code you would like to send, because in an emergency scenario, every second counts. 5 seconds. 3, 2, 1. All right, let's see the results. All right, pretty good. So in this scenario, there has been no loss of function or critical loss of equipment, resources, or systems, specifically life support systems like oxygen, temperature control, power. And however, there is a member of your team that has suffered a medical situation whereby your commander has suddenly dropped to the ground unconscious. And therefore, the most appropriate response in this scenario would be a medical response, where you dispatch a medical team to come and help your commander. Because there is no need for an engineering team, as there is no loss of equipment or function or systems, there is no need for engineering team, and therefore the most appropriate response in this situation is a medical team. So that's very good. Let's move on to the next question. Question 2 of 5. Your rover is losing pressurization rapidly due to a breach. You estimate you have 2 minutes before you and your crew lose consciousness. What do you do? This is an even more dire scenario than the last one, in my opinion, because your whole crew is at risk, and there is only, as mentioned, 2 minutes. Well, actually, there's 40 seconds. So make your response quickly. Choose from one of the 8 options. Yeah. There are a few things to consider in this scenario, so make sure you think thoroughly before you make your choice in 15 seconds. Five seconds. All right, let us review the results. So, most of the attendees have chosen red, and in this case, because this is a situation where you have equipment that has malfunctioned, in this case, the rover is losing pressurization, whether it's due to a breach in the pressurized cabin of the rover or some other system failure. So you will, in fact, need an engineering team to come and help resolve this issue. But in this scenario, you also have 2 minutes before you and your crews lose consciousness, and on the lunar surface, most likely, the emergency team will not be able to reach you in 2 minutes. And therefore, you are sending this code on the basis that you will need medical assistance on their arrival. Therefore, the most appropriate response in this situation is one where a medical team and an engineering team is dispatched, hence a red color code. This is one of the most serious situations that can occur on the lunar surface and requires a full-fledged response from your base camp. And also, it is a really fast scenario where everything can go really bad, really fast, which is, once again, demonstrates the importance that we have for a simple, fast-paced, color-based emergency code system. Let's move on to the next question. Question 3 of 5. You encounter a neighboring EVA crew that claims you are operating too close to their base. They become aggressive and shove one of your crew members. What do? You do like your crew members, so your response should be appropriate, but also firm. And in this case, it is a situation that involves other people, other astronauts, and so it can escalate quite fast, and therefore a fast and aptly chosen response is very critical in this situation, and you must choose in the next 20 seconds. Five seconds. All right, very, very good. Most of you have chosen purple, which is the correct response in this situation. In this scenario, there is no failure of mechanisms, no loss of function, no failure of systems. There have been no physical injuries sustained by any member of your crew as of yet. However, the well-being and livelihood of your astronauts are at risk of being threatened by other EVA crews. And therefore, in this scenario, the only situation which needs to be dealt with is the threat of physical altercations from personnel. And therefore, the most appropriate response for this would be the dispatch of a security team. Therefore, in this situation, it is a code purple, which is one of the codes that exists in Selene that is not very common in other terrestrial-based search and rescue systems. Usually everyone out there is there to help you, but on the lunar surface, it's a very complicated situation, so we need to be prepared for all sorts of scenarios. So while Selene is a very compact color code system, it still covers a very wide range of possible situations, and therefore it is a very versatile system. Let us move to the final question. Question 4 of 5. You are on an EVA and receive notification of a solar storm rapidly approaching. What do you do? This is quite a serious situation because solar storms are stormy. And so a quick response would be crucial. And no, an umbrella won't help you. Ten seconds. All right, so most of you have chosen the yellow radiation hazard code, which would be the most appropriate in this situation. There is a solar storm incoming. There's a very high chance that the area you are located will receive bombardment from radiation. And therefore it's very important that whoever's out there to help you is warned of this situation so that they can be appropriately prepared. So this would be the best case for this situation. Let's move on to the last and final question for all this time. So question 5 of 5. While on an EVA, you trip and fall into a shallow crater. Your crew knows your location. You are uninjured, but you can't get out. Which code do you call for in this situation? There's a lot of components to this situation. There are many details that you should consider before selecting an answer. Now, this one may not seem as urgent as some of the previous scenarios we've discussed, but it's still nevertheless an emergency and you require a response, and therefore a distress code should be sent out in this situation. Yeah, preferably in the next 20 seconds. All right, 3 seconds. Very good. So in this situation, you have no loss of function, no damage to systems, no injury or otherwise medical situations. There is no hostile threat. There is no environmental hazard. And you're not missing because your crew knows your location and you still maintain communications with them. However, you, whilst uninjured, are unable to get yourself back to the base, probably because perhaps the crater is some sort of obstacle inside that you can't navigate, or if your rover's broken and you can't go back to your base. You physically are fine, but because you can't go back to base, you need someone to be dispatched, and therefore in this situation, the green retrieval code is the most appropriate response. So that is the end of the interactive session. I hope you all found that enjoyable, and it was a good application to the Selene color code system. Congratulations to the 30 winners. Thank you very much. I will now hand it off to Nara.
Thank you, Jerry, for this incredible interactive section. Now we already have the idea, we are going to do the implementation. So talking about the implementation, we have 3 main areas that we have to think. We have the technical part, that is, we have a limited visibility about our astronauts in the moon. And why we have this? Because if we stop to think, actually, our astronauts will not ever have the satellite on top of them. So we have a limited visibility. We also have communication delays. So for example, you want to make a communication between moon and Earth and back to the moon, you take at least 2.5 seconds. And we have a planned but not already applied dedicated network that we need. And about logistics, of course, we have limited power, water, and fuel for our astronauts, and limited rescues and medical team. About legal, we need to think that every country that has the technology to be in the moon, it can go to the moon. So how do we do the cooperation and engagement between those countries? And what about the limitations of technology out space law? So going a little bit deeper in the technical part, we have already showed for you our color code proposed, but now I am going to propose you a parallel code, okay? So for each color, I'm indexing a number. So for example, for red, we have 0, for blue, we have 1, and so go on until yellow, that I'm indexing 6. And why we are doing it? Because when I do a transmission, we have a package of data to transmit. So think about it. It's probably easier to transmit, like it's less data to transmit just a natural number than, for example, the whole words in red, or even the RGB color code, right? So because of this, we are indexing some numbers. And with this, each package of data, I'm going to call it a bit. So we just need 3 bits to transmit a number, a natural number between 0 and 9. And considering this, we are also using as analysis a cost parser SAT system. This is a system already used in the Earth to emergency-like distress code. So when we have some incidents related to aircraft, ships, or even a person who is lost, we use this cost parser SAT. And this has 250 bits. And for all of these bits, we have basic data that has to be used. So for example, we already have the location of the transmission, and we have the code of the country about this mission. And using all this basic data, we just have 14 spare bits. But it's okay, because what I'm proposing for you is just 3 bits. So we already have more bits for example, transmit some image of the incident. So considering this, we are going to talk about remembering LunarNet. And for this architecture, we should consider that we have Earth relays, we have communication service provider, and the communication of each with our astronauts, with the EVA suites, are using U8F band. So for all the beacon proposing until now, we are going to use U8F band. So going to our beacon specification to use Selene code, we are going to talk about the link budget. Considering for our beacon the frequency that I have already told for you, and considering a worst case of distance between the astronaut and the satellite of 1,000 kilometers and a data rate of 400 bps, we have a link margin of 16 decibels. What does it mean? Well, a good link margin would be between 10 and 20, so it's a really good one, okay? And about the antenna, we have considered 3 options. We have a monopole that is compact. We have a dipole that is a higher performance, especially for stationary use. And we also have the microstrip patch. So this one is a little bit, is the better of the 2 others. So it's compact and durable, okay? And you would choose the one that is that is good for your requirements of hardware, okay? So going on, we are going to talk about the battery. To do our calculations of battery to the beacon, we are considering 6.6 ampere hour and 12 volts for 1 watt. And of course, we are not considering a 100% efficiency of our battery, but 90%. And considering it, we have 72 hours of duration. And this is really good because actually, if you start to think, if I have any big problem of the satellite, we still have energy to at least communication a distress code. Okay, and about the latency, unfortunately, we can't do a lot about this because, also I have said, the communication between Moon and Earth take at least 2.5 seconds. But it's okay because when we're talking about the moon, it's just 100 milliseconds. Okay, so summarizing our beacon specifications, we have considered the UHF bands. We have 72 hours of backup of battery. We have the 3 options of antenna, and we are considering just needing 3 bits of communication. So this is what it is about. It shows to us that Selene is not just a color code, it's not just a beacon, it's going to be the basic components for the future lunar operations. And now I'm going to pass to Zamara to talk about the legal implementation. Thank you.
Thank you, Nadia. All right, so far it's clear that we need a disaster code response, right? Then I have 3 main questions. So the first one is going to be how we're going to implement it. The second one is like which organization is going to be in charge of that. And the third one, what are the risks and how we can mitigate those risks. All right, so having said that, the first to keep in mind is the legal basis. So for the legal basis, we found the main foundation in the human right of life. So that is what we want to do here. Protect life of astronauts that they are considered as a humankind. Therefore, we're going to use Article 6 of the International Convention on Civil and Political Rights and Article 3 of the Universal Declaration of Human Rights. They protect life, all right? So in terms of space, we're also going to be able to use the Space Treaty, the Moon Agreement, and the Rescue and Return Agreement. Yes, the Rescue and Return Agreement normally is to use here on Earth. However, under the principle of extension, we're going to be able to apply that in the Moon as well. In terms of the supporting frameworks that are on Earth, so we're going to be able to use the same-day framework, which is for risk mitigation, and the Tempering Convention that is also for rescue. So we had kind of like the legal support. But something to keep in mind as well is that under international law, under the principle of extension, we're going to use international law as well, and in soon to that, customary law as well. So anything regulations like we had on Earth, by that principle is going to apply in the Moon as well. Still, states and even private companies, they have the obligation to prevent the loss of life, and especially there in the Moon. However, the next question is like how we're going to do it, because it's very hard to determine if we're going to do under a treaty or under just a framework. So we have in one side soft law, which is basically we can do as a guideline. Countries and even private companies, they're going to have flexibility if they want to take, or if they want to be part of that or not. And also, as the space technology changes every time, we're going to be able, if it's any modifications or something like we need to do, it's going to be more easy to do any change. For hard law, yes, we had some advance, which is like states are going to have responsibility, they're going to need to follow, and they need to adapt that under domestic law. However, a clear example of that a state doesn't want to sign treaties is the Moon Agreement, where we just basically have like 12 countries part of that. So we decide like the best option is to do by soft law, which means by guidelines, that's going to allow as well private companies to be part of that. And in soon to that, it's going to be more easy if we need to do any change or things like that. So that is the first thing. Basically what we are trying to do here is also learn the lessons from the COSPAS-SARSAT, and basically with that, like every country, the majority of the country, including China, Russia, are part of the COSPAS-SARSAT, so that's why we decided to go for that approach. Now, what is going to be the organization in charge of that? So we decided to do with the UNOSA as well, with basically working with the UN as a neutral coordinator, and the COPUS and the International Telecommunications Union. The reason why is because those organizations tend to be more impartial, and then countries are going to be more easy to be part of those guidelines. For the private sector, we also are proposing that any state that decide to be part of those guidelines, they can implement in their countries by own legislation, but internal domestic legislation, ensuring incentives, regular support, and benefits for those companies. And the long-term goal is basically establish space safety as a corporate social responsibility for private companies. So what is the next step for us is basically develop a global working group, pilot programs for the implementation and testing, and strengthen international cooperation. Having said that, international cooperation is going to be the key player in this situation, because that is the only way that we're going to be able to implement the system. Again, our main area to focus, or our main our main support is that we want to protect the right of life. Now with the risk. So with the risk, we, in our team project, we basically study different types of risks that we're gonna have here. However, the two main ones is gonna be the misinterpretation of signals. The reason why is because imagine we're gonna be dealing with different countries. Everyone has different ways to communicate, different backgrounds, different customs. So that is going to be the first problem. However, how we're going to address this risk is basically using an international code of systems. So in that sense, everyone is kind of like going to be able to speak the same language, right? And the second one is the transmission of the wrong code. Imagine you are having a solar storm near to the Faustini crater there in the South Pole. Obviously, you're going to be very much in panic, scared of something like this, right? But the good thing with this is like all beacon activation will have a response for the rescue team. So that basically doesn't matter even if you are in a stress situation and you get to press the wrong button, still you're going to have the response for the rescue team, right? However, the main thing to take into consideration here is training. That is going to be the key player over here. So basically, what we are proposing is like with the astronaut trainings, it must be mandatory to have training as well to how to use the beacon, how to react to those situations. That's all for me. Thank you. Now I'm going to pass the microphone to Tash and Lauren. They're going to speak about these conclusions and future recommendations.
Thank you, Zamara, for that wonderful overview. And thank you to the audience as well for sticking with us so far, especially relatively early on a Friday morning. So we do really appreciate that, and also the people joining us online here today. So Tash and myself are going to talk about the future recommendations and summarise everything that you've heard up till today. So it's important to note that I think that Anna mentioned this is really the culmination of the 4-week SSHSP program, but in reality the team only had 7 days to develop this concept from basically a blank slate to what you see here today. So obviously with lunar search and rescue being such a complex, vast topic, we couldn't possibly cover everything within that short amount of time. So here we're just proposing a few recommendations for further exploration and consideration. So the first one from a technical standpoint would be to ensure that we mitigate noise and interference during the transmission of the beacon, as well as considering communication and encryption protocols as well to ensure that data is transmitted securely. From the legal perspective, as Zamara mentioned, we propose establishing a dedicated lunar search and rescue working group, which could fall under UN COPUOS, which is already established, to encourage international collaboration and have those continuing dialogues to ensure that Selene can be adopted universally and have that flexibility as well to integrate with existing concepts and systems. Moving on to training, which has also been touched upon. So training will play a very, very big part in the future. There's also an opportunity for commercial partners and industry to spin into that as well and create that as their own market. So in Australia, we actually have startups working on virtual reality platforms specifically for astronaut training. So one way that we can leverage that is potentially to use Selene as an example to further do that training. We can easily switch between different emergency scenarios as well if we're using a virtual reality-based system. So not only can we train a variety of people spread out across lots of different geographic locations, but we can also use it to iteratively test Selene as a code in itself and continuously improve upon that framework. Moving on to considering the context of the NASA Artemis program and the Moon to Mars program in itself. Obviously for this project within this scope we were looking at lunar search and rescue, but it's also important to consider what are the next steps, what are the next milestones. And the moon is really seen as just a launch pad for further exploration into the solar system, with Mars being very much talked about in the media recently and on the horizon. So seeing how we can extrapolate Selene to work in other planetary environments as well, and what boundary conditions we might need to tweak are also something we would like to consider in the future. Finally, coming to ethical and humanitarian considerations, I think it's important, again, just to reiterate the need for international cooperation and to reflect on how far we've actually come in terms of human exploration. When we look back 60 years ago, really we just accept if you were in an emergency situation, the consequence wouldn't likely be good. There'd be no response team on hand to come and help you out. And now we're actually in an era where we have government programs and commercial industry and startups like Safety from Space working on lunar search and rescue systems. So I think that's really important and may influence how we think about future human exploration in the future, and really reshaping the cultural narrative as well going forward. So with that, I'd like to pass on to Tash to conclude.
Thank you, Lauren. The return of humans to the moon will mark a new era of space exploration. This era will see a wide range of people visit the moon, people from different nations, sponsored by commercial or government entities, people with different mission durations and objectives. It's important that all these people are protected while they're on the lunar surface, where getting lost or injured is immediately life-threatening. Lunar search and rescue is still in its early stages, and significant thought needs to be put towards distress. Lunar distress messaging faces two key challenges. Firstly, limited lunar communications infrastructure means that distress messaging has to be compact. Secondly, the moon has no established emergency procedures comparable to those in terrestrial high-pressure scenarios or even the current space stations. Our team recognised that both these challenges could be addressed through a colour-based lunar distress code, so we developed one. Selene was developed with careful consideration of the kinds of emergencies that could be faced on the moon. It allows an individual in distress to, within a single colour, communicate the kind of emergency they're facing and the kind of response and support that they require. As demonstrated during the audience participation activity, Selene is intuitive to an international and interdisciplinary audience, a very important consideration for a universal distress code. Development of a distress code is not enough though. We also needed to consider how we would implement it. We investigated and showed that Selene can be implemented within minimum viable lunar communications infrastructure. We also investigated legal and government considerations, suggesting an incremental approach to participation and the establishment of a lunar search and rescue consortium. As Lauren has just discussed, much more work is required for the refinement and implementation of Selene. However, we believe we've taken an important step towards the meaningful protection of human lives on the moon and beyond. Thank you. I will now pass over to Maddie for a Q&A.
Thank you, Tash. Thank you so much for attending this first part of our presentation and for engaging really well with the interactive activity. I think that given about 5 minutes of training on those color codes and the agreement rate we saw, you're all ready to go to the moon. So we have now entered the Q&A portion of our presentation. I have a few helpers here. So Adawit's going to run around with the microphone if we have any questions here in person. I believe that someone will give me a wave if we have any questions online, and I can see some lovely faces up there on our screen. And we also have in the second row here some of our team members who should be poised to answer the questions. We have Nara, Anuj, Lucky, Ben, and Shani. So, Heidi, you have the mic. Yep. Cool.
Check. Yes.
Yeah. So the question was, I believe, about the bit rate. So offering that minimal viable 3 bits, whether or not a bit error in those 3 bits would cause a change to the code, and what implications that would have.
Okay, thank you for the question. Like, yes, it's a very relevant question because, yes, bit errors can occur. But what we have considered in the COSPA SARSAT inspired data message structure, which has 202 message bits, and the remaining 48 are error detection and correction bits, which uses BCH coding, Bose-Chaudhary H coding, which will help in detecting if there are any errors in the bits, and if there are errors, it can be detected. So yes, from that perspective, we have investigated.
But if it's detecting overall errors, it will just reject the message.
Yes.
Wait for the message to come again.
Yes. Yes.
Okay. My second one is sort of related to some extent. If you're transmitting a separate color code for the incident, you have to be able to select that on some kind of keyboard, I assume in not voice activation. So there's 2 things. I've looked at systems, certainly in the military, where they've used a standard keyboard and tried to put that into the back of an armoured personnel carrier, where there are big, mean, tough soldiers, which are, they're cold and they're tired, and hitting buttons in the right order at the right time is quite difficult. I can imagine if you're wearing a spacesuit with gloves, there's an issue there. And the second issue, there are very, very few safety systems that rely purely on colour. Most of them rely on colour and positioning, especially signal systems on trains and car and traffic lights. How did you think about the human-machine interface for the type of system?
Absolutely. So as for the positioning, you would consider the beacon would ideally have a position sent within that signal. Could you repeat the first part of your question? Sorry.
So the positioning one was not the position of where the person is, but the position trying to hit the right point on the keyboard. So mobile fits. The fat finger problem is a real issue for most people who are in emergency situations. The other one was the colour, because you have to be able to recognise the colour. And I thought it was important because one of the slides, the yellow wasn't yellow, and you couldn't see the black. And that's just in these,
Absolutely, especially in EVA suit where you have a big finger. We did discuss this briefly, having like a dial system, for example, where you just switch between them. But ultimately, this is outside the scope of this framework. We're ideally just trying to set up the framework for the colors, and then implementation would be for teams in the future to set up specifically. Yeah, exactly.
There was a lot of back and forth on, if you have a colorblind astronaut, what would be the scenario there? But having that foundation of the colors and then allowing different countries to perhaps, attach their word for that color to that, you can still use verbal cues and written ones to assist, we hope. We've got a question at the back. Oh, we've also got an online. All right, we will do this one, and then we'll do the Francois will take his question.
Phone rise from safety from space, and I'm very impressed about the presentation and the report you provide within such a short time. And yes, it's one comment about the color code. If the astronaut's not in the good condition, or say is unconscious, so it's unable to press the button, or press the wrong button, if the hand's shaking, and what do you do in this situation?
It would depend on the code required, but ideally for all of them, or as many as we could, we would have automated systems. So something like a health rate monitor. If we see a spike of some kind in their blood pressure or something, we could immediately send out medical aid, a code blue. Or if we detect a pressure leak, we can send out a code red or a code orange, depending on the severity of it. There are certain codes like a purple for security purposes that would be difficult to automate. You would require someone to call in that code, but ideally they would all be automatable. Future.
So you're saying the spacesuit have some equipment sensors to measure the astronauts' physical condition, like
Yes, exactly.
heart rate, blood pressure. So also you send periodically to the base, and you monitor what's the condition he is in. Is that correct?
Yes, absolutely. Medical and engineering, like the systems themselves. And for code black also, for example, someone else would have to call them because the person is missing. We don't know where they are, so it wouldn't be called by you.
Yeah. Thanks. Thank you.
Thank you.
Thanks. Francois, would you be happy to ask your question?
Yes, thanks a lot, and congratulations for the very good presentation and also for a very interesting report. I have many questions, but I will restrict myself to two. One on technical aspect and one on more political aspect. On the technical aspect,
That's a code purple.
what was that? Can you still hear me?
We can
back online.
Okay, but there is this echo issue. I don't know what's going on. Okay, the technical question is related to the power. You hinted at the need to... Something is going wrong here. Okay. You hinted at the need to have a good power source to make the system work. Can you please elaborate if you have worked on what type of power source you are thinking of? Is it solar power, nuclear power, or any other power? And to which extent it has an impact on the system and the Selene framework. The second question is on more political aspect. You mentioned, and I fully agree, the need for international cooperation. You also, at the beginning of the presentation, and it's also in the report, you talk about Artemis and a little bit about ILRS. And I was wondering whether in your work you had looked in detail at the ILRS initiative with China and Russia, and to which extent these countries and the ILRS program could fit with the color code system you are providing. Thank you.
We'll start with the first technical question.
Yes. Thank you for the question. Yes, because power systems, yeah, everything is important and everything comes at a cost. Like even a few grams of increasing in your architecture can cost like exponentially. So speaking of technical implementation from power perspective, we have given it a thought that it will be independent from the power system which is supporting the EVA suit or the rover. It will have an independent power source in the form of lithium-ion batteries, which are durable, which have been proven to be space grade, and like they have good energy efficiency as well. So we did some calculations, and we started with a duration, like for how long do you want our batteries, do we want our batteries to last. So we had that requirement of around 2 to 3 days for the rescue operations to occur. And then we have some already standard batteries, space grade batteries, which are available based on lithium ion based or lithium manganese based batteries, which work at 12 volt voltage. And we also, based on the link budget calculations which we did to get a good enough link margin, we thought that the EIRP of effective isotropic radiative power of the transmitter, for the beacon transmitter, if it is somewhere around 5 watt, using it is expected to consume around 1 to 2 watts of power, raw power. So for that amount of power, we came upon how much should be the battery sizing, like around 6 to 7 Ah. So that is how we did the calculation. I hope this answers the question. Yes, thank you.
Okay, I will talk more about the technical part related to the second question. So when we are trying to make the technical part, we didn't have time to look at all the architectures available or proposed. So we have to make a choice. We chose it for the Lunar net that is related to Artemis. That is, we have a cooperation with a lot of countries. So unfortunately, we couldn't go in deep in the parts related to China and Russia.
I think I can help answer your second question. We did look into the International Lunar Research Station, which is founded by China with the support from Russia, and there's a lot of countries from, you could say, the global south that are also working with them. But we were looking at the search and rescue, or SAR, and what's happening in practice terrestrially on Earth. And if you notice, I think in Zomara's presentation, we showed that regardless of how different the political systems or tensions there might be between different states, on this specific issue, the value of preserving human life comes first, and we thought we could then extrapolate this and apply it to the lunar environment. And that's why we also proposed making guidelines instead of saying hard law, and also using neutral systems and forums so that it would encourage collaboration and international cooperation. And I think if you look at, say, with China's space program, I know that also NASA has a lot of open source designs open to anyone who wants to use them, and you can look and see China's space technology and how they've also been able to incorporate some of those features. So we are really hopeful and confident that this would be something, ideally, that would also be well adopted.
I think we'll go to Suyin next. Sorry, I missed you that first time. I think you must have raised your hand first, and then we'll take another in-person question.
Yep. Okay. Well, it's great to see everyone in Adelaide. I'm joining from Toronto, Canada. And just a bit of context, I'm from SHSSP25 alumnus. And I'll wait for the echo. Are we okay now? Hopefully. Okay, I'll just pause.
There.
Thank you so much. I really enjoyed that presentation. It was great. I'm more curious about how you conceptualized what basis of literature did you consult in coming up with the colour code system. There is established literature on the safety communications, and there's been a lot of research on the efficacy of safety retention and cognitive load. So I was really interested in what basis of literature you consulted in coming up with your framework.
So first we looked at what emergency system exists on Earth and who are the ones who are currently proven to be working and what are the possible problems that had already happened. The main one we looked at, which is the most close to ours, is of course the hospital color code system. Where it is well documented and we have access to a lot of the protocol and the information. But one of the information we got from looking at those type of literature was how having a non-universal system code could result into problem. We found an example where the different system, different color code from different hospital led to a really bad incident, and this is how we decided that it was really relevant to stress on the importance of creating at the beginning a universal one. I'm gonna pass.
One thing that I want to add is when you are relating it to the space, you have to consider that if you see in our report, we have made some math related to do, for example, in the ISS, when you're trying to communicate and say, I need a rescue, I have a problem, the time of this kind of communication from the ISS to the Earth, we don't have a really big delay, but also, like I have said, when we are talking about the Moon to the Earth, you have a 1.25 seconds of delay at least. So if you have this delay, together with a delay of a talking message, for example, or writing one, this will take more time to help. So if we just send color using the base of hospitals, it's like 100 more times faster. Okay.
Awesome. Thank you for that question. And I'd love to add, I'm a teacher by training, and cognitive load is very important. And we hope that, with enough training on the system, that it'll become second nature when it comes time to call an emergency if the worst does happen. We'll go to you in a moment, but I just want to check. I believe that we've had, we're addressing the online questions. Suyin, if you're able to type your question out, I can read it out. Oh, you have it. All right. Quite know if that's going to work out, but.
Suyin, do you want to try your?
Is that all right? Okay, I'll just wait for a second. Okay, so I'll just try this again. Hopefully this works this time. But I was just saying greetings, everyone, from Toronto, Canada, alumnus from SSP25, and also former ISU Dean. Really happy to see everyone online, and congratulations on an excellent piece of work and presentation as well. I understand that this is the shortest SHSSP in history, so really everyone should give a round of applause and pat yourselves on the back for completing that challenge, and I hope that you've learned a lot from this process as well. Similar to Francois before, that I do have two questions as well. I'll ask the first one, and maybe because of all the audio issues, that I was going to pause and then ask the second one, but I'll just ask both, and hopefully you can jot it down and still remember it. The very first question is, I was wondering whether you could detail further who your target audience is, who you expect will actually implement this proposed Lunar emergency protocol, and what is the sort of time frame that you expect? So this has to do with what the immediate next stage of this project would be if you really want to take it further. Because we all want the TP results to be impactful. The second question, I think quite a few of the questions already were about making this distress messaging system accessible to more people. And I was wondering, in your development of the system, did you consider the role of disabilities and impairments when developing this color scheme? For example, it's pretty commonly known that color blindness or color difficulty in differentiating between colors is fairly common, especially, well, both in men and women. Have you given some thought about how this might be considered, and how these like different scenarios might be handled? So, for example, I think many individuals with this impairments might actually be more disadvantaged in these scenarios that you've been talking about. And how would you make this whole entire system more fail-safe? So hopefully you got all of that, and thanks very much.
It sounds like we've got our audio issues sorted as well. So thank you. I'm so glad you asked that.
Thank you, Suyin. To answer your first question as to who, this is meant to be an international cooperation to have a mass appeal to an international audience. We want to market this and really have this implemented by every nation that we possibly can. Colors can be distinguished, we'll get to the disabilities after, but colors can be distinguished by international audiences, and as long as we have all the same training on the same codes and the same responses, then we can all be on the same page. So if a Chinese base, say, receives a red code from an American base, there is no confusion as to what they need to do because of that international cooperation. So we want this to be as widespreading as possible. And then, Shani, did you want to answer the disability?
I would also like to add about the target audience is that it is both directed to companies that provide satellite communication services, but also space safety services like weather detection. It is also targeted to the space agency that, of course, want to preserve the life of their astronauts, but it can also be linked to insurance company that will be really interested in assuring the safety and the life preservation of their astronaut and maybe more in the future, the space tourist. On the accessibility question, we of course thought about the different problems that can happen. We also know that vision health issues can quickly happen in space. So this is why when we looked at, for example, the Apollo mission, we saw that the beacon emergency system was a dual voice system. So in case of vision impair or loss, we can imagine the implementation of a voice activation emergency response. And of course, at the moment, when we are looking more about how it can be implemented for the Artemis mission, because it's the next step in lunar exploration. But at some point, we hope that tourists and other people could go to the moon and may also need or benefit from this system. And in that case, it will be interesting to look further into incorporating disability response.
And just to add to Shani's discussion on disabilities, we had robust discussions about how we could make things more accessible. We considered things like hand signals, like before we settled on how we were going to, whether we should have additional methods to make it more accessible. But one of the things we discussed is, if you noticed when Nara was discussing the technical section, there was the colors with the corresponding numbers for the different bits. So that was something we could also consider. That number corresponds with the color.
Thank you. Just adding, what she said is perfect. So when we're talking about colors, so if you have, we are thinking about the future. So if you have, for example, tourists in the moon and they have some disability, and they can't difference, for example, the colors, the person can just use the name of the color, for example. And the system will translate it as just a number, the indexing number, as she had said. And then when it go to the Earth or to the lunar base, if it's necessary, you can translate the name of the color or other way to identify it. So the transmission is just indexing. This is okay. And how we use it, like the user superface, it's used the better way that it can be to our public.
Thank you, guys. Now, do we have any more questions in person? We've got Michael, and then we'll go online.
No, thank you, and congratulations. I found the project that you have delivered both very well researched and very well written and presented. So I think you've done a fantastic job. My comment is that in this audience, and there are representatives of organisations involved in private human spaceflight, and I'm sure that there will be considerable international interest in the research you have done and the report that you have written. And I wonder whether you have given any thought to what the next steps might be in disseminating your recommendations and the result of your research. And perhaps just as a comment, I would certainly encourage you to think about the idea of presenting papers at international events, international space events and conferences, and also sending your report to the critical bodies involved in international in planning international programs, and also the policy dimension of international space.
We are submitting this to the IAC.
So I'm told that you are submitting an abstract to the IAC in Sydney in October, so that's a good start.
Yes, and thank you so much for the kind words. That means a lot that our work has resonated with you.
Okay, I can start. About the IAC, this is already considered by the team to do it. And by myself, I can assure you that these proposals it's being talked about in the Air Force in Brazil, because I'm from the University of the Air Force related, so we are already talking about this. This probably is being transmitted for the alumni from the uni. So, for example, we are trying to do it.
So the communication and, in a way, the marketing of this system is going to be one of the most important steps to ensure its application in the space sector. And also, this report come in this International Space University, who has also a big network. So we definitely can see how what we do here and how we can do our best to communicate on it on conference, and also with the ISU library, and just talking with other alumni will definitely help and be at least the first step in this implementation.
I agree there. I think that all of the alumni in the audience will, of course, know that we're about to head off from our 12 respective countries back to our space agencies, research institutions, as well as the even broader alumni network. So there's certainly exciting avenues that I think will come out of that. I think we'll go to Maurizio online.
Hi, everybody. My congratulations for your excellent effort and for what you achieved in the relatively short time you had available. I have one question, which is organized in two different points. The first point is about the operations. Now, color code might be a very practical way to communicate an emergency. But the way you are referring to looks a bit, you are having in mind what happened on Earth, which is, in the civilized countries, a very structured environment, and where things could react according to protocols and infrastructure that help. I mean, on the moon, let's take the examples you propose yourselves. Let's assume you have, or we have, a pure medical aspect, and we raise the right color, which I don't remember, of course. We cannot expect the ambulance to come with the blue lights in a few seconds. we cannot expect having paramedics accessing the body of the crew in distress. Reality is much more complicated. So it's good to have the information that possibly, but not certainly, is a pure paramedic issue, but might not be so simple to have only paramedics. And if you have a dispute with our neighbors, what we do? We call the police, and the police come with the blue lights in a few seconds with the car. So the reality on the moon is a bit more complicated than that, and color code might be a practical way to communicate the issue, but not necessarily we may expect that to a color code information may correspond an equally simple reaction. And the second point of the same question is that I think we have to, I believe, we have to make a serious distinction whether the issue is within the same consortium. In this case, it's relatively easy to have prepared beforehand a full set of understanding of exchange of information, whatever you need to intervene and act, while it could be pretty difficult to do the same across different consortia. In order to achieve that, we need to have an excellent preparation ahead of time, which could only be possible with the willingness by everybody to exchange information, to cooperate on an international ground, which unfortunately in the given circumstances might be more difficult than a few years ago. This is my comment, and I would be grateful if you could elaborate a bit on these 2 points.
Yep. Thank you so much for your question. I think, first of all, we have to look at the scope that our paper was considering. The moon, the lunar environment and lunar exploration, we understand that it can be a hostile and surprising environment. It's completely different from Earth, just as Andrew pointed out, the limitations, the difficulties. I think what's most likely going to happen in terms of looking at it from the legal, ethical landscape is that we're probably going to have the law catching up with the advancements as we explore and discover the lunar environment. What we tried to do with our paper was provide a solution. If you think of it like a puzzle, we are providing one piece, an essential piece we believe, that could then help address the issue of actually letting astronauts and people who are on the moon, when they're in an emergency, be able to communicate that and get a response. And you're right, there needs to be a development of other structures, but just like, when we were discovering, it's kind of like the Wild West, there was people who were explorers, it was a little bit difficult, and then slowly over time, infrastructure and systems will be able to get implemented. But what we can take heart in knowing is that if you look again at the way that different countries, different states who are vastly different and at times at odds with each other have gotten together and worked to keep preserving the sanctity of human life, especially with search and rescue, and we are hopeful that that can also then be applied to the lunar surface. Let me know if I've answered that question, or if I'll pass this on to the other Q&A experts.
Okay. Thank you. I will explore a little more about the second point. So being really practical, let's guess, okay, that you have a problem. Yes, it's really difficult to get a lot of countries in the same consortium. Okay, so let's say it's in the moment, it's really, we can't do it. So it was considering this, that the beacon that we have made the specifications is a really low power with low bandwidth, with low data, so it is compatible with a lot of different hardware. So we have considered this to be an easy beacon to add to our hardware, okay?
And if I might just add, with your comment on, sorry, what was the second part of that question again? Might just move on to the next question. Philomene.
I can't help but Damon would have known about Selene, the whole movie would have been a bust and Jim Green would have just been unhappy. I want to congratulate you on your presentation because there were really smooth transitions and it was very logical in order. And the whole premise of this is, the basis of communication, and that is so important because that's what all our situations are, whether it's an astronaut or it's a space tourist. So my question is, was there any thought, and you mentioned already that you're a teacher by training, as am I, was there any thought given to this apolitical body that might be a school, might be school children? Because if you could teach this Selene code and embed that in education system, then it would be international, and the gamifying of it would just resonate so well with the way we're doing things in the school system these days, at least in Canada.
Thank you so much for that. I might actually jump in on this one. I very much agree. I think that the accessibility of it, the appeal of the colors, and the idea that it's very altruistic and can help astronauts in a lot of scenarios is really appealing for education. And when we came up with this and when I saw the final report, I definitely was already thinking about all the outreach that we could accomplish with it. So to sort of answer your comment, yes, very much.
Can I add something more?
Absolutely.
Like, I remember some of the SHSSP had a project where they had to set up a university on the moon. Like maybe in near future, if we have space colonies on the moon and there are universities and schools on the moon, we surely will ensure that the Selene is a part of the curriculum.
Excellent. All right. We've got a question in person here, and then we'll move to Rodrigo.
It's not a question.
That's okay too.
Just for your information, all systems already can do two-way communication, is text and voice. So just like a walkie-talkie, you can push the button, have a short message, and say what happened. It's a voice message. And also we will work on video as well. Currently, last year, we had a test. The voice and text is successful, can transmit from one terminal to another by the satellite. Thanks.
Thank you. And I agree, it was something that we spoke about a lot when we started this project, is we didn't want to reinvent the wheel here. Like, people are already much wiser than us, are working on the actual infrastructure and tech, so we wanted to do something that would complement that. All right, Rodrigo, let's see if this audio works.
So first of all, congratulations for such a great TP, and especially done in such a short amount of time. So it's really totally impressive. I have two questions. The first question is to understand the choice of encryption over digital signing, because you surely want the signal to be received by as many parties as possible. So encryption is not really, I'm not clear the role, but it's important to prevent spoofing, and so maybe digital signature might make more sense. The second question is, during the project, did you got any unexpected or surprising finding that you didn't preview from the beginning? Thank you.
Thank you so much for your question.
Yeah. Okay, thank you. Talking about the first question about encryptation, this is, I agree with you, it's better to the message goes to most people that we can have to help who is requesting. But so because of this, if you say in our reports, actually encryptation is the future applications. We thought that is a sensible content, so because of this, we needed to do more research related, so it's related just to the future applications. What we have in our appendix is just a suggestion to consider, not the real final that we would love to have.
And to add to that, we did have a like conservative approach regarding the amount of data that we wanted to transfer, but still we made an attempt to incorporate encryption also, like without adding much of an overhead on the total message structure. So it was an attempt, and yes, as you mentioned, like spoofing could be a problem. Yes, so we have put some thought about that. Yes.
Awesome. And to answer your second bit about findings, I don't know if I've got agreement here, but I thought an interesting one that came out of it was that code black didn't actually pop up until quite a bit of the way into our thinking about this. So we grouped up into a few groups and basically dumped and brainstormed a list of all the things we thought could go wrong on the moon. And code black kind of just came to us towards the end of the process, and we figured it was encompassing a lot of cool things.
Another point that was surprising, at least for some people of the project, it was when we were trying to change the colors with the level of disability and vision. At some point, I couldn't defer any color. So because of this, we considered to do the indexing too.
Thank you. And we've got a question in person from Anderson.
Thanks. This is a question on behalf of an assessor who's not able to be here today. So we note the absence of business and management considerations. Several publications recently suggest public-private partnership in the framework of the Artemis project, including communication, including a PPP contract for Lunar communications. So is there a reason this was not considered in this team project?
Yeah, so we did look at where we were looking at what topic to decide to do the TP on. We did consider like a financial analysis. We had different ideas, but at the end of the day, we were looking at focusing on making this easily accessible, and also something that could be adopted regardless of budget, regardless of industry, whether it's public-private, because our focus really was more looking at whether or not this could be something that would be implemented across different environments. In terms of the business applications, we do believe that I think, as Shani said earlier, that there are so many different audiences that could implement this. In terms of public-private partnership, we understand, like, so in the Artemis mission, we've got a consortium of both national space agencies as well as private space companies. And if you think about it, the bottom line is that it's a lot of resources and money goes into training astronauts as well as getting missions to the moon. So the last thing you would want is to lose those astronauts, if you think of the biggest resource. And so our focus really was this would, by ensuring a unified, universal lunar emergency color code that would reduce risk, and also in terms of reputational risk, financial risk, probably insurance costs would decrease, hopefully. And so that's what we were looking at. I think in terms of the limitations with time and also the scope where we were looking more at a technical solution, I think that we did cover a little bit in the future applications part of it, but yeah, that is something we did consider.
On the business plan, in concrete term, what we propose will not really make money, but will most likely save money, because astronaut life is valuable, human life is valuable in the insurance point of view, but also because of the training, the cost of the training, the cost of getting the astronaut there, and the importance of being able to do every step of the mission. It also has another aspect that can benefit the market of the space sector is the trust. Because when a current space actor put the human life as a priority and not as something that may happen, we create trust between the future consumer that will most likely be the future space tourist.
Awesome. And another thing we were really excited about this project is that although there's not necessarily an aspect of commercialization or that private industry aspect, we didn't think that astronaut safety was something that should be commercialized. But this is inherently a spin-in of a lot of Earth-based technologies and systems that already exist. Now, we've got time, I believe, for probably these last two questions. So I might go to Claudio online and then to our lovely lucky last here. And if you do have more questions, please don't hesitate to chat with us after the presentation. Claudio?
I would like to give the floor to Juan de Dalmau for a question. Juan, please go ahead.
Thank you. Lona, I hope you can hear me without echo. It is 1 a.m. here, and therefore I'm not sure which color button I was supposed to push to raise my hand. But thank you, Claudio. My question is about obtaining buy-in from all the international partners that you have mentioned, but you were not able to talk to them yet. Have you thought of continuing with simulation games like the one you played with us, with all these international partners? Do you think this could be an interesting tool? Or have you thought of other ways to really make this into a universal code? Congratulations for what you have accomplished in such a short time.
Thank you so much. Yes, and I definitely think it would be fun to go into an international negotiation diplomacy meeting and start playing some games with Selene. Any thoughts?
Absolutely. We'd probably have to begin with some localization of changing the phrasing and wording to fit international audiences. Changing words one-to-one, of course, don't work when translating a language. So we would have to find partners to work with to help us translate, and then we could begin spreading this to a wider and wider audience, and hopefully play some more games. That'd be nice. Thank you.
We did actually run very similar tests to this with our actual cohort. So we tried to have, that representation of the 12 different nations, lots of different backgrounds. And so those are in the appendix of the report if anybody's interested. And we tested about 30 not so simple edge cases to really try and nail down that agreement rate. Thank you, Claudio, and thank you, Juan. Lucky last.
Thank you. Like Juan, I have a project continuation question. So firstly, great work. I really appreciated that. It was a great presentation to watch. After this evening, you leave the SHSSP bubble and you go back to your real lives. So my question is, who is going to champion this? Who's going to take this forward and go out to the international organizations, go out to the companies that are working on this, present at IAC? Have you decided who's going to continue to participate and who's going to leave it here and go back to their jobs or their families and their lives?
Do you want to answer?
I was technical lead, so I'm very invested in this. I put my hand up to sort of be the point of contact. But after this presentation, we're going to have a bit more of a discussion, and I imagine I've already heard from a lot of people that they're keen to stay on. So I'm definitely keen to be point of contact, but I think there's quite a few people who want to stay on.
Thank you, Tash. And yeah, as you alumni know, we're going to be a very tight group, I'm sure, for the months and years to come. So I'm sure that the project will stay with us in a lot of ways. All right. Now I think that concludes our Q&A portion of the presentation. And just before we finish up, I have a few final thank yous to make. So of course, thank you to you all for attending, and thank you for the presentation from our amazing team. But I also really want to extend our thanks to Safety from Space, who provided some significant direction and advice throughout the course of our project. Our project leads, Emmeline, Mark, and Anderson, for being on the ground with us, providing some additional material, briefings, and all-around moral support during what's been a very, very busy week. Our scholarship providers and participant sponsors, without which many of us would not have had the chance to come and do this program. So their support is extremely appreciated. And if anyone from those organizations are online watching today, hello. Not pictured on screen because there are simply so many are the dozens of ISU and UniSA staff support, and everyone from the TAs and the organizers to the people who brought us coffee during the late nights. They were incredible with their coordination, their delivery of not just the TP, but the engaging extracurricular workshops and programs that we did, and of course for the mentorship that they provided. And now, last but not least, I would really love if everyone could give one more round of applause to the participants of the SHSSP25. From 12 different countries, there are 29 of us. You can see our names up there on the board. We've been living and working here in awesome lakes for a month now and making some lifelong friendships along the way. We could not be more proud to have presented to you the culmination of our program today. So thank you.
Thank you, everyone. I couldn't have done that thank you any better, but I also want to acknowledge that the assessors online joined at 1 a.m. and other times around the world. So we appreciate you participating, being active, engaging with the participants, this team project. And I think a lot of those questions were really great in getting the gears turning on what the next step is. So hopefully you all take that, take it to the IAC and into a future project. I'm going to ask that the assessors meet online. I believe you have the link, and then in person here, if you want to meet in the foyer, we'll walk to the other room where we can continue our discussions. And everybody else, go ahead and have some tea, some coffee. That's outside, and then we'll meet back here. I'll come out and grab everybody, and then we'll provide some feedback.